Continuing our journey, we encounter the central molecular cloud, an irregularly shaped area spanning 1,600 to 1,900 light-years and weighing over 60 million solar masses. This region contains numerous stellar nurseries, gas nebulae, protostars, and remnants of supernovae. The cloud primarily consists of dense hydrogen, with temperatures ranging from 50 to 600 Kelvin, 223 C to 327 C. Spectral analysis reveals the presence of carbon monoxide, methyl alcohol, and hydrocyanic acid in addition to hydrogen. Moving away from the galactic center, we explore the galactic disk, the most striking part of the Milky Way. It comprises two components with distinct properties. The thin disk, approximately 1,0 to 1,300 light-years thick, has a visible radius of about 50 light-years, tapering off gradually towards the edge where the outermost stars lie up to 100 light-years from the center. This component contains about 80 of the galaxy's visible mass and was the last component to form. The thick disk, comparable in diameter to the thin disk, is 4 times thicker and sparser. Composed of old stars, it has minimal interstellar gas. Observations and mathematical models suggest that the Milky Way merged with another galaxy called Gaia Enceladus between 11 and 8 billion years ago. This hypothetical structure contributed billions of stars, interstellar gas, and dark matter to our galaxy. As a result, most of the Milky Way's thick disk formed, and a surge of gas led to increased star formation. Spiral arms are the most prominent structural features of the Milky Way's disk. Typically, two major arms, the Scutum Centaurus arm and the Perseus arm, and two minor arms, the Norma arm and the Carina Sagittarius arm, are identified. Occasionally, a fifth large arm, named after the Cygnus constellation, is also considered. Galactic arms have a high density of stars and interstellar gas, resulting in a star formation rate 3 to 5 times higher than the average for the galaxy. Young stars begin their lives in open clusters within the arms but gradually disperse due to weak gravitational forces. Along the Carina Sagittarius arm, we encounter a fork connecting it to the Perseus arm. This stellar structure spans 11,0 light-years in length and roughly 3,500 light-years in width. Referred to as the Orion arm, it is the location of the solar system, 27,0 light-years away from the galactic center. The Great Rift. From our planet's perspective, the center of the galaxy appears as a dark abyss. This region is known as the Great Rift, a space area that obstructs our view of the majority of the Milky Way. It is filled with enormous clouds of interstellar dust and gas, with a total mass up to 1 million times that of the Sun. Although the Great Rift is nearly opaque in the optical range, its matter actively emits radio waves and thermal energy. Spectral analysis data indicates that the clouds consist primarily of hydrogen, along with a small percentage of more complex compounds such as ammonia, alcohols, and amino acids. The Great Rift is believed to be a potential birthplace for stars, although it will take some time before the first stars illuminate that region. Beyond the galactic disk, while the Great Rift is still relatively inactive, let's move on to explore beyond the galaxy's disk. Although the bright and well-defined arms of the Milky Way attract much attention, there is more to our galaxy than meets the eye. Upon closer inspection, we discover its largest and most diffuse component, a halo. The visible part of the halo, which has a spherical shape, extends up to 260 light-years away from the galaxy's center but accounts for only a few % of its total mass. The halo contains numerous globular clusters composed of exceptionally old stars, over 12 billion years in age, as well as several massive stellar streams. For instance, the Sagittarius stream, consisting of several thousand stars, encircles our galaxy in an elongated ellipse that is nearly perpendicular to the main plane. Computer modeling indicates that all these stars were likely gravitationally captured by the Milky Way from a dwarf satellite galaxy called Sagdek. Sagdek is located 50 light-years away from the center of the Milky Way and will eventually be completely assimilated by our galaxy within several billion years. Another dwarf galaxy has already experienced a similar fate. Situated in the Canis Major constellation, it was partially destroyed by the Milky Way, which gravitationally pulled millions of its stars away, stretching for 200 light-years and intermixing with other stars. This stream of stars, with a combined mass of approximately 100 million solar masses, has already wrapped around our galaxy 3 times. In addition to bright yet rare stars and clusters, the halo contains significant amounts of gas with temperatures reaching millions of Kelvin. It is also believed that substantial amounts of dark matter are dispersed near the Milky Way, forming the so-called dark halo. Extending up to 2 million light-years, the dark halo emits negligible electromagnetic radiation and can only be detected through gravitational interaction. The dark halo remains an unsolved mystery, but it greatly contributes to the overall stability of our galaxy. Conclusion: the Milky Way is just one of countless structures in the universe. Together with other galaxies, it forms the local group, which is itself part of the Virgo supercluster. Galaxy clusters assemble into filaments, which in turn form even larger scale structures. The cosmic scales are so immense that they can be difficult for the human mind to comprehend. However, our knowledge of the universe continues to grow more accurate with each passing day, and the mysteries of the cosmos gradually yield to human perseverance. This is the power of the human mind and progress, and we take pride in being a part of it. And so, my friends, it's time to summarize the 2-part video on what does the Milky Way really look like. According to the prevailing scientific hypothesis, the Big Bang brought our universe into existence approximately 13.8 billion years ago. Primordial gas compressed by gravitational waves gave rise to the first stars, illuminating the universe and forming intricate structures. The Milky Way, categorized as a barred spiral galaxy, has a disk diameter of about 200 light-years and a halo extending even further. It contains billions of stars, brown dwarfs, planets, and vast cosmic dust and gas clouds. Dark matter, composing around 90% of its mass, plays a significant role in gravitational interactions. The central region harbors a supermassive black hole, Sagittarius, and densely populated star clusters. The Milky Way merged with another galaxy, Gaia Enceladus, contributing to the formation of its thick disk and increased star formation. The galactic disk comprises the thin and thick components, with spiral arms rich in stars and interstellar gas. The solar system lies within the Orion Arm, approximately 27 light-years from the galactic center. The Great Rift, filled with interstellar dust and gas, obstructs our view of the Milky Way, but it emits radio waves and thermal energy. The halo, containing old stars and stellar streams, surrounds the galaxy and is believed to capture stars from dwarf satellite galaxies. The dark halo, composed of dark matter, remains a mystery but contributes to the galaxy's stability. The Milky Way is part of the local group within the Virgo supercluster, and together with other galaxies forms larger-scale structures. Human knowledge of the universe continues to expand, unraveling its mysteries. The power of the human mind and progress drives this exploration, and we invite you to join us on this journey. If you're ready to embark on the journey of unraveling the mysteries of the universe with us, feel free to show your support by liking this post, and let's stay connected.